So other things we can do to overcome the problem of the atmosphere is to just get above the atmosphere. This is the whole reason why we have space-based telescopes. If we're above the atmosphere, we don't have to worry about weather, we don't have to worry about turbulence, we don't have to worry about any of that stuff. Now, something I want to stress, we are not putting telescopes in orbit around the Earth to get them closer to the objects we want to look at. The stars and galaxies are so far away that the couple hundred miles that it takes to put these things in orbit does not make any difference at all. Okay, so we do not put satellite telescopes in orbit around the Earth to get them closer to the stars. Now, space-based telescopes also allow us to start studying types of light that we can't normally study. So one of the other effects of the atmosphere that we have to deal with is that it actually blocks certain types of light. Okay, so, for example, right through here in the visible spectrum, the light is able to penetrate and get all the way down to the ground. That's also true out in the radio region. But in parts of the infrared, the ultraviolet, X-ray, and gamma ray regions, these types of light do not actually penetrate all the way down to the ground, which is good. Personally, I'm really happy that I'm not bathed in X-rays and gamma rays all the time because of the amount of health risk that would involve. However, if you want to study anything in the infrared, in the ultraviolet, X-ray, and gamma ray regions, you're going to have to be able to get above the atmosphere. Okay, so this is another reason why we want to put telescopes in orbit around the Earth, is to allow us to start seeing types of light we can't normally see from the ground. So far, I've talked about pretty much just optical telescopes. Telescopes that are designed for the visible spectrum. This is actually the part of the types of telescopes I like to work in, because it means that this is at least kind of sort of like something I could see with my eye. However, we've mentioned that there are other types of light that we can't see, and there are astronomers who study that type of stuff as well. The only other type of light that we're going to be talking about is radio light. Okay, so a radio telescope is actually very similar to a radio dish or a satellite dish. Okay, it works on the same principles. We have some sort of curved surface that then focuses the light onto a receiver. Okay, and it's the exact same thing that we talked about with reflecting telescopes. The light hits the mirror, collects together until we can then capture the light, record it in some way. Now, we mentioned earlier that radio waves have the worst resolution. That's because radio waves are very, very big, and the larger the wave, the worse the resolution is going to be. Well, there are a couple of things we can do to overcome that problem. One is to just build bigger telescopes. Remember, the bigger the telescope, the better the resolution. This is an image of the Arecibo radio telescope in Puerto Rico. For a long time, it was actually the largest radio telescope in the world. Okay, the way they did this is they actually found a natural crater at the top of a mountain, and then they made it into a radio telescope. So they built a telescope out of the top of a mountain, which is kind of awesome. Now, unfortunately, because it's the top of a mountain and built into a crater, this means it's going to have some limited range. You can't just point a mountain into wherever you want in the sky. Now, they do open it up a little bit because of how they can position the receiver. Okay? So it's not just one very thin region of sky they can detect. It's actually pretty good, about, I want to say 30 degrees wide, although it's been a long time since I looked that up. That might not be right. Okay, but it does open up a little bit. More recently, China has actually developed an even larger radio telescope. I don't know all of the details on that one, though. But it's even bigger, which means it's going to have better resolution. Okay, so this is one way of doing it. But even so, just building a giant telescope isn't going to overcome all of the problems. So we've developed what is known as interferometry. The idea of interferometry is you don't use just a single telescope, a single radio dish. Instead, you actually use multiple. Then, as you record that data and then you add it together in a very special way, then you get a resolution not of the size of just the single telescope. Instead, the resolution becomes as if you had a telescope that was the size of the distance between the two small telescopes. So it's as if you had a much larger radio telescope than just those small dishes. And so in this way, we can just spread out the dishes at greater distances and get better resolution. There's actually a radio telescope that spans all the way from California to Virginia, meaning that when we use this interferometer and add up all of those signals together, it's as if we had a single telescope that spanned the entire continental US. That thing gets some really, really good resolution. More recently, we actually had a collaboration of several different telescope networks that actually spanned the entire globe, from the US to Europe to Africa, also to Japan and even Antarctica. All of these telescopes were trying to add all of their signal together to get a resolution so good that they could actually see a black hole, and they succeeded. You can actually go and see those images. Now it's blurry, but remember, this thing is crazy far away and is comparatively super tiny. And using these techniques, we can actually see it. Absolutely amazing. Here is our 5th lecture quiz question. We put telescopes in orbit to get them closer to the objects we study. A true, B false. Go ahead and think about it, and we'll discuss in just a bit. All right, so do we put telescopes in orbit to get them closer? No, that is absolutely false. The reason we put telescopes in orbit around the Earth is to get rid of all of the terrible, nasty effects of the Earth's atmosphere. Okay, so the answer is B.